So far we've had only one type of variable that we've made. It's been called int, and it holds whole numbers. Okay? We've discussed that integer variable. Okay? We've discussed that this integer variable can hold a 32-bit number, whatever that means. We don't really care what it means too much, but basically it is, in binary, a number with 32 ones is the biggest number it can hold. And, oh, I'm not in binary here. Hold on. In binary, if I do 32 ones, like this, it will tell me my biggest number I can hold is... keep going. Did I go too many? Yeah, I did. Back one. There we go. 4.3 billion is the biggest number that this variable can hold without overflowing and going on to the smallest number that it can hold. Okay? So we looked at integers that way. It turns out that... what happened here? Oh, I'm way too zoomed in. It turns out that the actual biggest number is half of the size of the 4.3 billion. It's like 2.1 billion something. Reason being, I need just as many negative numbers as I need positive numbers. So that's all good. We did a lot of tricks with that. Like we would see what happens if we added, equals itself plus 10 or something like that. Then we would output it, see what happened to our variable. No problems there. Okay. Next variable type. Recording. Next variable type is one that just holds letters. Okay? It's called a character variable. Yeah. Who just showed up here? Hey? Justin, who is that? Who just showed up here? Yeah, streaming. Okay, so second variable type, guys, don't use it that often, but it's called char. I'll just give this one a name because I'll call it letter 1 because they hold letters. Just single letters, or any button on the keyboard, actually. Any like keyboard press is considered a character. Character variable. Okay? Let me just see how big that is in the memory of the computer. I'm going to use my size of command. And I'm going to put in the name of my variable. Just to check it out. Okay? Let me run it. It is... Shh! Be quiet in the back row, guys. Okay? Just wait till I'm finished. So it's 1 byte, which means on a calculator... that it is 8 bits. So the most amount of information a character variable can hold, is that 8? Oh, I need to go to binary. Hold on. 4. Yeah, there it is. The biggest thing it can hold 256 values only. So that's the only amount of information that it can hold. It can hold up to 256 values, and it's good for like keyboard layout because every keyboard press. Well, we'll have a look here. Let's look. So I'm going to let letter 1 equal the letter A, for instance. Here's how you do it. You do it in single quotes. It's kind of awkward. We won't use this variable type too often. Okay? And then if I go to print it out, letter 1, it will just print the letter A on the screen. It's not really any great mystery there. Okay? I can let it equal like numbers. There's the number 8 if I want. Okay? I can let it equal symbols on the keyboard like semicolon or quote or whatever, or bracket. Anything like that. Anything that represents a keyboard press. Could be useful later on when we go to use the keyboard to actually do stuff like move objects around the screen. But here's the interesting thing about these letters. You can switch them all to integers. Here's how you do it. If you have a variable that's a character type and you want to see what it is as an integer, keep in mind the computer loves numbers more than it loves anything else because it works with just ones and zeros. So when you give it the letter A, it actually thinks of it as a number. Let's see what number it thinks of it as. Apparently it thinks of it as the number 97. Okay. What about the little b? Let's see what it thinks it. Probably 98 if I had to guess. Yeah, 98. Let's see what it thinks of the space bar as. Thinks it's the number 32. Okay. Let's see what it thinks of as the number 0. Do you think it'll be 0? No. It's actually the number 48. Okay. So if you want to know what number is represented by every letter, there's this thing called an ASCII table, and you can look that up. I can't remember what ASCII stands for. Abbreviated North American Standard Code for Information Exchange. Okay. Whatevs. But you can find a list here. Look at these ones, guys. There's some really weird symbols here. Let's say I want to make this symbol in my code. Anyone taken physics and use that phi symbol? I think it's phi or psi or something. Let's try to get it to write it. So it is the number 232 on this list. Okay. So if I go to print 232 here, it's just going to print the number 232. But if I want to switch it to a character, I'm just going to write CHAR in front of that number, and it should be able to switch it to a character. There it is. A weird little symbol. Okay. Let me find another cool one. There's some really weird ones. A lot of these are based on old typewriters, like carriage return, vertical tab, line feed. These are all. This is all based on old typewriter stuff. Look at this one. You could make ASCII art with this one. How about infinity, 236, okay? I've decided we're going to do face tattoos for our icebreaker, so you could do like an infinity sign on your face. Wouldn't that be cool? So that's characters. Oh, check this out. Remember I said the highest number it'll go to is, well, it has 256 total values, so this is 255. Apparently blank. 254 is a square. Let's go 254. It's that nice black square there. 256 is going to flip back around to 0 because C++, it never gives you an error when you go over the highest number. It just runs it back around, right? So if I do 256, it's actually going to see that it's 255 is the lowest, and it's going to go back to 0, which actually isn't anything. But let's say I go 300, right? It should be like 256 plus 36. It should give me the dollar sign or something close to that. Let's try it. Even though 255 is the highest number, it will let me go over. And it gave me the quote one. So let's look at this list. 255 plus 36 is like 291? Or if it wrapped around, it would be like, I think it grabbed like, I think it wrapped around to 39. Anyways, yeah, it always wraps around. It doesn't error out. You could even put minuses in here, I think. And we just go minus 90 from your highest number. It won't complain at you. Okay, so characters are numbers. They're the same thing, except a character variable can only hold 256 numbers. Not much to it. Does it run or no? Yeah, it does. It's the weird little letter A. Good, good. And then the last variable type that we'll learn about today is float. That's the one that holds decimals, which we haven't really talked about yet. Okay. Variable that holds decimals. And this one has a huge range of numbers, like, because it has 32 bits, so I think it uses like half of those to describe the like decimal number, and then the other half to describe the power. So floats can be numbers between like 0 times 10 to the minus 38, and the highest number is like 10 to the 38 or something. So it can deal with really huge numbers. It's just not as, the computer is not as efficient at dealing with them. Let's look at an example and see if what happens with the computer when we put a decimal in here. So I'm going to go 50.76, for instance, okay? Now, let me look at that in my, I'm going to stop my code and look at it, okay? We'll learn about how to stop your code later, but there is my variable called decimals. Right now, this little letter e represents times 10 to the power of. So it's 4.48 times 10 to the power of minus 44. That's just junk, whatever was in there. Whatever ones and zeros were in there, converted it to a decimal number. Then when I complete that line, look at this. This is important to note. I said it was 50.76. What does the computer have in its system? 50.7599983. Okay? This is why a computer is good at integers and not at decimals. It can't always get the exact decimal, because it's got to try to convert ones and zeros into a decimal number, right? And sometimes it doesn't have enough precision to actually get the number exactly right. It's okay for us, like it's 3 digits. It's off by like 1,000th or 1/10,000th of a digit. But that could be an issue in banking software or something, so you got to be careful if you do that. But that is how you make decimal numbers, okay? Can you mix decimal numbers and integers together in math? Let's have a look. I have a decimals. I also have this number 1. This is an integer. Number 1 is an integer. Decimals is a float value. It stands for floating point. Let's go decimals times number 1. One's an int, the other's a float. What do you think the answer will be? A float or an integer? Let's look. It's a decimal number. Okay. Okay, so you can mix integers and decimal numbers together, no problem. Okay, so try Lab 5 today.